Hey everyone! Today we're continuing with our series titled Mastering Reusable Solutions for Revit Plugin Development. In our previous sessions, we explored data structures, the iterator pattern, and its implementation in C Sharp. I highly recommend checking those out before diving into today's video. You can find all videos in the series organized under the playlist Mastering Reusable Solutions for Revit Plugin Development course. So it goes in order, so you can start with the first one, with the intro one, and just go in order. I don't name them like starting with the same like prefix. Is because I just try to make them general. So if you just want to learn about like data structures and IEnumerable for like that has some connection to Revit, you can just watch that out. But if you really want to follow with the course and understand what is going on, it's way much better if you check these out prior to this video. So in this episode, we'll be constructing our own domain of classes inspired by those found in Revit, so including solids, curves, geometry elements, among others. So basically, the domains that which logic the domains, the objects, the classes which logic is revolved around in Revit, right? So you when you get element in Revit and you want to get its geometry, you get things like solid curves and other stuff. And this is what we're going to be kind of replicating. We're going to be creating this mock versions, right? Something that looks similar to this because what we need is just data and then we can just write our own additional functionality on them, and later we can jump straight to the Revit. So before we begin, please take a moment to like this video, subscribe to the channel, and leave your thoughts in the comments below. If you're interested in more comprehensive courses, be sure to visit my website. The link you can see in front of you, but also the link is provided in the video description. So let's get going. So now it's time for us to start coding and trying to implementing this geometry element. So we're gonna think as if we have no Revit whatsoever, that we're building our own Revit. Let's say we're we're creating our own Revit, and we're gonna have in our application geometry element. And currently our goal is to create a domain for this. So domain is basically everything that will that our app revolves around. Usually you have business people, right? The ones who actually domain experts, the one who actually understand the ins and outs of the industry. So, for example, when Revit was kind of built, usually that involves a lot of people, but primarily it's about having developers who can create this from the programming perspective and having domain experts who know things about this industry. They know why this wall should be built this way, why it makes sense, what processes we need to follow, what are the best practices, and so on and so forth. So they are well aware of all these approaches. And usually developers need to become domain experts to be really good at what they code for. So if you want to be a BIM developer, you gotta understand BIM. That's the main idea. That's what I'm trying to convey. But we're gonna try to kind of see how they went with this, and we're gonna try to imitate a similar thing. So we can see that geometry element at the very beginning, it inherits from geometry object. So if you go to the geometry object, we can see the hierarchy. And let's just create a couple of them. We're not gonna create all of them, but let's create a solid. Let's create like point maybe, right? I'm not gonna go too much in depth. Or let's just create line, solid and line. I think it's curve, and then I think it's the deviation from curve because here we have curve and then we have line. So it's actually quite a big hierarchy, but it's not what we're aiming for here. We're aiming for more kind of understanding. So this is where I'm gonna go there. Let's remove everything that we have written there. It's not that important right now. I would even remove this project at all. Yeah, to be honest, I'm gonna remove this at all. Uh, yeah, I'm gonna delete it in from the file system or not. If I need, I can recreate this. It's pretty fast, nothing was cool here because what I want to try show you is that how we start from tests. So here I'm going to create a new project. For the time being, I'm going to follow the .NET 7 part. And here I'm going to go with the unit test project, and I'm going to go with Axe Unit because that's the kind of framework of my preference. And I'm gonna name this Geometry Exploration App Tests. That'll be unit tests for the time being. But I don't want to get into very specific details of tests and TDD. I'll touch on them slightly, but again, it's not the main idea of it because my main focus here is that to show how we can kind of understand Revit's objects, Revit's domain, implement our own just for better understanding, from better comprehension, and yeah. So we're gonna test some units part, right? Some kind of unit functionalities, like when there's no external things that can affect it. Yeah, let's create it. Then I'll show you how we can do this in Revit. For the time being, it's way much easier to do it this way. And also, I want to go to the NuGet packages and have their fluent assertions. That's a nice library that allows us to verify if things work correctly. But again, don't worry too much about this, and yeah. Probably it's good to have your project for your domain, but for the time being, I'm going to write everything within a testing environment, right? I'm going to be using what is called a record. Probably if you're a Revit developer, you're not aware of this, unfortunately. But if you, or to keep, we can use records, right, to keep things simpler. You can go with other components like you can create classes. If we look at the record, it's basically that's the syntax for this, how it's created. Behind the hood, right? It's still class. It's nothing new, right? It's just, again, most of the time, these things are just for like easier kind of reducing a lot of boilerplate code. So what they've done is that they've created a class, right? That's what happens behind the scenes, behind the hood. So we created a record here, but compiler sees it as a class. And the main idea of this is that it's immutable. You cannot change this after it was generated. So if you go like var wall and you say a new wall and some kind of brick, let's name this. That's more of a material, but let's name it this way. Now I cannot go and say name and put a new name there. It cannot be done, right? So that's the idea of this, that that is immutable. And if you want to create a new one, you just go there and say, like, for example, new wall, that'll be new width, because that's what is allowed for this. That's what is specifically implemented for records. And you go with the new name, let's say concrete. And you're not changing. That's what's really important. As you can see, it returns the wall what it wants from me. Use new expression. Yeah, it tells me that you can practically create the same one, but I just want to show you how it can be done using this approach, right? So it just goes with clone. So this is the method that Record has behind the scenes. So if you go there and you look for this, probably you'll find a method called clone clone, where it kind of regenerates this wall. So it creates new instance each time when you change this. I really like this concept that comes from a functional programming. And on my channel, I'm going to be talking more and more and more and more about functional programming, especially in C Sharp, because that's what I'm truly like excited about, and I really like it. But that's kind of the main idea. It's just way much easier to create things. Let's see if we follow this approach or not. We'll see how that goes. I'm gonna stick. I just showed it, right? But I think we're gonna go with classes, so it's easier for you to kind of work with. Abstract class. And let's see what we have here. So here we have a geometry object that is probably something of an abstract class because it's too abstract. It has methods like equals and get hash code, so it doesn't that much of things. If we look at members, again, There's nothing that much. So it's basically like an indication of that we have it right there. So so we're gonna have it like this, abstract class geometry object, right? Geometry object. So that is just an empty class, let's say. Then we can have classes like curve, right? Curve, which will go from geometry object, and here I think we can use that way. The primary constructor can be used there. So for example, double length, right? And here or not, is that comes from oh, that's in previous. That's the next version. I'm sorry. Okay. Um, I just wanted to get the feel for the syntax the way we have with records. So let's go double length. Let's suppose that our curve only has length. Oh, I kind of used. And let's create a get only property. Actually, this again, as you can see, it's also immutable, so we cannot change length, right? And we could have easily used records there. Secure, the reason why I'm not using records is because in some cases we do need to have classes because we will break the semantics of records. And I don't want to go too much in depth because it's more again about functional programming when we talk about records. It's not what we usually think of classes because usually we think of classes as things that have data and behavior, but when it comes to records, it's about separation of these things when we have data and behavior separately. Let me show you what I mean by this. So we have a curve. Let's have a solid. So we're going to have solid geometry, geometry object. Let's have a constructor. Let's pass a volume there, right? So we're going to say that our geometry can have a volume. We're going to go with the read only, not read only. I want to getter so we can access this. Okay, so we have like usually that's what our element is generated of, right? And so if we look at the geometry object hierarchy, at this kind of bottom part, that's all about like solids, lines, different kind of curves, points, and so on and so forth. But on the way, we saw that we have geometry element, which is kind of pretty vague, right? It doesn't kind of tell us a lot, and which is kind of like IEnumerable of geometry objects, right? So at the same time, that is a geometry object, and at the same time, that's IEnumerable of this. So let's kind of do the same thing in our case. Oops, I'm gonna go back there. And let's implement this. Then we're gonna break this into class. Public class, public class geometry element, right? Public class geometry element, which is what? Which is geometry object and I enumerable of this geometry object. So this is what's it about. Um, I don't want to get into the details of implementing this myself. So here we'll use something a bit of a like a decorator pattern, where we just accept here an IEnumerable of this geometry object, right? You're gonna see how that works, right? Geometry objects, and we're gonna just store this in the read only field. I'm gonna check for null because I like in constructors, if something goes invalid, we throw exceptions. That's a fail fast rule. When something goes off, if something goes off in your program, it's better to kind of fail it fast. In functional programming, they usually follow kind of a slightly different approach. They don't kind of follow with exceptions that much as we do here. I'm gonna show it later in my later videos. And I'm just gonna reuse this in my from this like get enumerator, and I'm just gonna return this. So instead of implementing my own, I'm gonna reuse it from something like list or array, so I don't get bothered with these things. Okay, so we have geometry element. What else do we have on the way of geometry object? We also have a geometry instance because all these things like face, if you go to the face, we see that that is a direct implementation of geometry and it just has a bunch of cool kind of methods, right? Like get regions, get surface, like whether it intersects or not. Basically, a lot of great functionality that is purely related to the face. So let's go back to the geometry object, right? And here we have geometry instance because like mesh, point, polyline, that's kind of self-explanatory. But what about geometry instance? It's also something kind of interesting. It's geometry object, right? And even if you look at the geometry element itself, it's not that it has so much behavior. Again, it's like a data structure, right? It's a container for this. And as I mentioned, data structures are not only about storing them, but they also about performing some operations on this collection as the whole. So for example, if you go get transformed, that means that it returns a transformed copy of the geometry in this element. So whatever is inside this will kind of get transformed. So my main focus is that it has some behavior, right? That performs as a whole on the element in it. And the geometry instance kind of interesting there. If we kind of read this, it says that it's mostly encountered in family instances, but that's not something that we worry right now about that much. And as you can see, it also doesn't have that much functionality on the like face, right? Because face is like this end element that a component contain, and we can kind of start operating with this. But geometry instance is more like um, is more like a tr I'm gonna explain this via whiteboard. I think that'll be easier. But as you can see, gosh, it even has get document. Revit API is always like it's pretty awesome in the way how they manage to connect domain with database so much, right? With document. Their domain objects, all their domain objects should know about domain. That's kind of funny always. But maybe there is a good reason behind this. I don't know if there is, but maybe. But they kind of made life difficult for a lot of developers for this. So as you can see, the main idea is that they have some methods that return geometry element, right? So it's also more like a container, right, that holds it. So let's kind of have it as well. So let's create a public class geometry instance that is geometry element is gonna have like some method that returns geometry element, and for the time being let's just implement one of them, get instance geometry. What we should return, let's again pass it via constructor because I don't like in Revit itself that is somehow implemented. In our case we don't have Revit, we implement it from scratch. So I'm just gonna have like and say I'll accept it, right? Use it as a read-only, throw exceptions if everything goes off. And I'm just gonna return, oops, it shouldn't be this. It should be just, let me go back. I messed up. That should be geometry element, like that. No, read only, throw exception if that goes off, and return geometry element, something like that. So yeah, so we can easily reuse this. Okay, so we kind of go with most of things that I want to discuss here. So let's go and create a folder. Let's create a directory. For the time being, I'm just gonna keep this in the task project. I'm gonna move everything there. I'm clicking Control Shift R to refactor. Then I'm saying move to folder, and I'm gonna do batch movement to folder. So I'm gonna say to the domain, and let me pick geometry object, curve, geometry instance, and solid. That's what I want to pick there. Usually it's gonna be in the separate kind of project. We'll kind of move it a bit later, and it's not gonna be that much of a difficulty. Uh, in the TDD kind of approach, that's a test-driven development approach. That's a technique when you build your software. So imagine building a program, but it basically starts with tasks. So even without having anything, it would be like even without having a domain. But I understand that that will be it's not that always people implement it this way, so it's just more of a guideline, and you gotta understand its leverages and what it gives you. I pick this approach here to explain things because it's way much easier to comprehend info. For the time being, I'm gonna treat this test environment as just as an environment for writing code, and I'll show you how that works. So first, let's just create a geometry element, right? So let's imitate the thing that we have here. When I go, let me go to element. I think that's there, right? When we obtain this. So from elements, we get the geometry element. So that's what happens usually with Revit, right? We get geometry and we obtain geometry element. So let's kind of start working with this. So geometry element, new geometry element, a new geometry element. Inside this, we need to pass a list of geometry objects, and that's where I showed you that instead of implementing our own, we just kind of provide their semi-enumerable, and we have a bunch of them, like arrays, lists, like whatever you want. Here, I'm gonna say that let's suppose I have a curve that is of length like 100. I don't care to be honest. It's just a bunch of data. Then I have another geometry element there. I can have it because it's a geometry object. So here you can see that it's more like a tree. And then we'll go to whiteboard and represent this so you can understand this better. So then we can kind of go again with some curve like this. And then inside this, we can have new geometry instance, new geometry instance and have some geometry element, right? And geometry element accepts like an array of things. So it's more like it's pretty kind of, yeah, not that easy to understand some of these things at the very beginning because it's like a tree like hierarchy. Okay, and let's stop with this, right? For the time being. Let's kind of go like this. Like this. I don't care. But that's what we have. And as you can see, we may go on and create like this tree-like hierarchy there. We like again, I want to go back to the idea of the data structure. That's the main concept lies in the fact that we have data and we gotta structure data in some way. And that's the way it's kind of structured. So basically, this is kind of imagine this happening behind the scenes when you get the geometry element, but of course, it's kind of picked up from real objects. So let's kind of represent this on the whiteboard. So let me go to the whiteboard. I gotta move a bit there, and let's kind of think about what we have there. Let me take my tablet. Okay, what the hell is this? Okay, we have a tablet there, and let's start drawing things. So I'm gonna jump back and forth between the code and this thing. Okay, let me see if that won't. Yeah, that works. So we have geometry element at the very top, as you can see. So let's suppose that we have this workflow when we have, oh gosh, I'm sorry, when we have Revit element, right? When we have Revit element, and we obtain from the Revit element this geometry element, right? Geometry element, geometry element, geometry element. So if I go back, gosh, it's not that. Uh, if I go back, that's what we have here. So this is what we're kind of testing there. It has curve solid. So basically this geometry element is representation of something like this. So it has, gosh, I have a very uncomfortable position right now, but okay. It has solid, curve, like, okay, it has curve, it has solid, but at some point it has another geometry element, right? Another geometry element and this, another geometry element is like you can see right now that is more like a tree structure, right? And it has a curve. So it has a curve. And then it has a geometry instance there. Geometry instance there. We call, and it contains curve and three solids. So curve and three solids. Curve and solid, solid, and if we go again, and we have solid there. Again, I'm okay, but it's not that important. So as you can see, it's very like some tree kind of structure right there. So that's the main idea. So it's like we have some nodes there, right? So we have some nodes there, and they kind of lead us to other things. So it's not like we go linearly, we go more like a tree structure. So this is what you gotta understand from this. Again, this is about data. So just sum it up at this point, we have data that everything revolves around. So in Revit's logic, it's geometry things like curve, solid, and other stuff. And when you get it from element, they are stored in some specific way. Right. Usually it's not that complete. To be the truth be told, usually when you get it from just like wall, it will be pretty easy to get all of them. When you get it from families, that's when things got more interesting because the geometry instance gets added. But that would be nice to kind of have implement this on our own and then kind of move our implementation to Revit and see how we can adapt it there. So we understood that it's not just more about linear things, but it's more about like tree-like structure. But at the end of the day, they say that that's IEnumerable, where it's kind of like a linear way of doing things, but it's not quite. But again, IEnumerable can be pretty much anything, anything that can be iteratable. So this is our first thing. So we have created a small domain with what Revit may have, right? And now we're gonna try kind of implement some actions for it. Thank you everyone for watching. As always, like the video, subscribe to the channel, leave some comments down below. I would really appreciate it, and that would help the channel grow. Again, thank you for sticking up to the very end, and see ya.